Hey guys, today I'm going to talk to you about writing C++ in the Arduino software. So the Arduino development environment is an open source software that is available for everyone to download and to use. So I get on to the Arduino website, click download, and you're good. It is written in a C++ programming language. It's actually written in its own kind of C++ language. It's a little different from the one that we're normally used to, but all of it is pretty much the same thing, syntax-wise at least. When you first open the software, you have the main two functions, the setup and the main loop. The setup function lets you call all your pins, lets you set up all the pins, your inputs and outputs, and will only run once. It'll run as soon as you start the program up. Again, it'll only do this one time. The main loop will iterate through the main program repeatedly, and it will call any of your subprograms or subroutines that you put inside the loop. So once you get your program written, you'll then take a micro USB cord, plug one side into the computer, the little micro part into the microcontroller, and you can upload it from there. The Arduino has a lot of capability to create and do a lot of really cool things. So if you see at the bottom there, the microcontroller is plugged into and connected to a bunch of different LEDs. You can have each LED light up at the same time, or you can have only certain LEDs light up at a specific time. So if you want, you can have all the red LEDs light up, and then all the green, then all the yellow. You can write all that in the software using C++ language. The picture to the right is a little mobile robot that I created and programmed in C++ for a course I'm here taking at Millersville. So Arduino in school, there's been a case study conducted on students that has Arduino labs implemented into the computer science courses. At the end of the study, the students were asked 3 survey questions. The questions were, the first one was using the Arduino platform, using the Arduino platform in the labs enhanced my understanding of hardware and software concepts covered in class. The second one was, using the Arduino microcontroller enhanced my learning experience in the course. And the third was the Arduino contributed to a positive learning experience in the course. More than half the students answered that the Arduino labs enhanced their understanding of software and the hardware. So you see to the graph to the right, the statistics were very high and the outcome was very positive. So most of the students strongly agreed to questions 1 through 3 that they all pretty much enhanced their learning capabilities. So the little firefighting robot, I made this for my capstone in one of my courses. The main goal of the robot is to navigate through the maze to find the room with a fire in it. The fire is represented by a little candle, and it will eventually extinguish the flame using the fan. It has sensors, fan, machine vision, and a bunch of other different stuff on it to help it navigate fully autonomously through the maze. So the camera on top will look out for 2 superheroes. It'll look out for the Flash and the Green Lantern. The way it does that, it'll detect color and tell each one to get out of the maze. So if it sees Green Lantern, it'll tell Green Lantern, hey, get out. And it'll say it on the little LCD screen. You can see it right behind the fan. And if it sees red, then it'll tell Flash to get out. So like I said, it's fully autonomous, so I won't be controlling it by like a controller or anything, like tele-operated. The sonars that I have, one on the front and one on the right, will help it guide it through the maze. So if there's a wall in front of it, it'll see the wall and turn around and adjust itself accordingly. It also will see an open gap to go into the room using the right sonar. So fully autonomous, you can do all this in the Arduino software with C++ programming language, which is really neat since it's made for physical computing as well, or physical applications, I mean. So you have to connect the software using a microcontroller to the actual application itself, to the actual projects you're doing. So to do this, you get a small micro USB cord and connect it to the computer, and then one other side to the actual microcontroller. The microcontrollers are small, compact circuits that can be used to program and reprogram for specific operations to control larger devices. So they control large devices like radio communications, drones, mobile robots, and a whole lot more. The Arduino microcontrollers have a digital input side and an analog input side. Each side provides different functions. So the analog side will actually output data values, like actually number values, while the digital side only output ones and zeros. So for the sonars, I put them on the analog side of the microcontroller. That way, if there's a wall in front of it, I can actually see how far away the wall is compared to the sensor. If I put it on the digital side, it'll just tell me a 1 if there's a wall, 0 if there's no wall. The digital side is you can use it for like the flame detector. It's a 1 if there's a fire, or 0 if there's no fire. So each one has its different functions and uses for it. There's also a whole lot of different types of microcontrollers, all used for like different projects. These two are the classic ones. The one on the top is a basic Arduino microcontroller you can get in any Arduino kit. And the one on the bottom is a Teensy, which I use for my project in my class. There is actually a weather drone being developed right now that is used by weather stations to collect data and track weather patterns. Excuse me. The drone uses sensors programmed in full Arduino to collect the data. It can also track temperature and humidity and can capture images of the horizon in different altitudes. So the sensors, I believe, can also help detect like how far off the ground, like what the altitude is for that drone, which is really neat. The flight path of the drone uses another application called Mission Planner. I looked a little bit into this, and Mission Planner uses more thing of a GPS so that the station on the ground can track where the drone is and program it where the actual course is for the drone. So where they want the drone to be or how high and like that kind of stuff. So in conclusion, there's a lot of possibilities for Arduino C++ in industry, mostly for like robots, drones, a bunch of different applications. Normally, C++ is used for computer software, like programming video games or other kind of software devices, but now it can also be used for physical applications, like I just said. So not only is C++ for computer scientists, but it's also used with physical devices for engineers as well, all their projects. There's more excited, and thank you.